So we've spoken about what's happened until today with the cryosphere, but now let's talk about what's going to happen in the future, or what we think will happen in the future, the predictions for the cryosphere in the future. And in this image, it shows a number of things which we've already spoken about, which are already happening. But because of climate change, we have changes in the water cycle, in the transport of heat, obviously carbon dioxide in the atmosphere. And we can see that many things are already happening. If we look on the right, first of all, the ice sheets, Greenland and Antarctica, are reducing in their mass balance. We're having less ice. We're seeing more melting occurring for the ice sheets. If we look for glaciers and snow cover, we're having a decrease in the coverage, the thickness of glaciers. Snow in some places is disappearing. Instead of snowfall, we're having rain in the winter because places are warmer. The permafrost temperatures are increasing, and so we're seeing that the grounds are thawing. We're seeing buildings are falling over, trees are disappearing, and we'll talk about it in the next class, that one of the main consequences of this, when you thaw out the frozen grounds, we also have a thawing of the organic matter, and often we have a release of a large amount of methane gas, which can also impact the climate. We spoke about the sea ice is also decreasing already and is predicted to continue. All of these parameters here are predicted to continue to change in the same direction in the future. We're seeing increases in the ocean heat content, which is resulting also in more melting, increasing in sea level, heat waves in the ocean, and on and on. All of these trends that we've been talking about now, that we've seen until today, are predicted to increase in the future. Again, if we look at the differences between the massive ice sheets, which are Antarctica and Greenland here, the two different colors, the pink is for Antarctica, the blue for Greenland. These are looking at the data from satellite, the squiggly line, and then if we take other combined data sets to estimate the change in the mass in billions of metric tons, we see they agree fairly well, but there are some disagreements. But again, from about the 2000s, we see this dramatic decrease in the mass balance on these two massive ice sheets on the planet. But what's predicted to the future? So here we can see predictions from various climate models in the IPCC report out to the end of the century, 2100. So these blue lines show the average predictions and the range of the predictions from the different IPCC models. This is only for the Arctic sea ice extent. So again, we're talking about an area of millions of square kilometers, which in the 1900s up to about the 1960s, around about 8-9 million square kilometers, the coverage that we see over the Arctic in the summer months. Again, this is in the summer when we have the minimum. And it's predicted that we'll get down to maybe for this middle of the road scenario, 2 million square kilometers by the end of the century. But if you look at the red curve is reality. This is what's actually happening. And the surprising thing, once again, is maybe us scientists are underestimating what's going to happen in the future. If you look at this red curve, it's happening a lot faster than we expect. The models predict that by the present, if you see, say, the 2020s, in this region, we should have maybe 6 million square kilometers coverage in the summer. But we're seeing that those numbers already occurred in the year 2000, and we may have a lot less ice covering the North Pole in the summers by the time we get to 2050. So where some people say the scientists maybe are exaggerating about global warming, when we look at the models in reality, often we're underestimating what's actually happening in reality. Here we can also see, again, looking at the Arctic sea ice at the end of the summer in September, we can see both the historical data shown in the observations and modeling, trying to simulate what happened in the past in the yellow and the reds before the year 2020. And then we can see the predictions, what's predicted to happen for two different scenarios, the low emission scenario in blue, where by 2100 we'll maybe have a 50% reduction in the area covered by ice in September. And then if we look at the pink curve, we can see that we may get to zero, no sea ice covering the North Pole by the time we get to the end of the century. So again, this depends on the scenarios, what's going to happen, what's the rate of warming, but the situation doesn't look that good. We're definitely going to continue this trend of decreasing the sea ice, especially in the summer months when it's getting warmer and warmer, and when we also have these feedbacks which are active. Again, the feedbacks are related to the solar radiation. In the winter, it's completely dark in the North Pole. And the reduction of the sea ice, particularly over Greenland and Antarctica, again, the sea ice over the North Pole, when it melts, it doesn't impact sea level rise because it's already floating in the oceans. But that's just a few meters thick, we said. If we look at what we have over Greenland and Antarctica, we have kilometers of ice. And this, once it melts, it goes into the ocean and causes sea level rise. And as we mentioned, it's very difficult to bring that ice back onto the land. And so that's going to have dramatic impacts on sea level rise. And here we can see the forecasts for the future for different scenarios. And all of the scenarios are kind of the same by the end of the century. If we're looking at 2100, that's not too far off. But this graph goes out to 2300, in a few hundred years into the future. So by the end of the century, most of these scenarios say that could be that we'll get to 1 meter sea level rise around the planet. But look what happens by 2300 if we do nothing. Even the moderate, the best optimistic scenario says we'll have 1 meter sea level rise. And if we look at the pessimistic one, we could get up to 4-5 meters rise in sea level by 2300. That's, again, a huge amount of sea level rise, considering that we've built all of our cities on our coastlines around the world, assuming that sea level is going to remain constant. This will have a dramatic impact, and unlike temperatures, which may go down again in the future when we take out the carbon dioxide from the atmosphere, once the sea level goes up, we're going to have to live with that, because as I mentioned, to reduce sea level, even if we cool the climate, we have to build up the ice sheets again on the land. And we have to produce snow, we have to produce ice sheets, which takes hundreds of years, if not tens of thousands of years. And as I mentioned, in those regions, say over Antarctica, there's not much snowfall there. It's a desert. So it'll take a huge amount of time to rebuild those ice sheets. And therefore, we can go for centuries, if not thousands of years, we'll have to live with any sea level rise that occurs because of the disintegration of the cryosphere. And finally, we have a summary of the movie from NASA, which kind of pulls everything together and discusses the cryosphere from all different aspects.
Though cold and often remote, the icy reaches of the Arctic, Antarctic, and other frozen places affect the lives of everyone on Earth. We start our tour in Antarctica. Where they meet the sea, mountains of ice crack and crumble. The resulting icebergs can float for years. Ice shelves surround half the continent. They slow the relentless march of ice streams and glaciers like dams hold back rivers. But the region is changing. As temperatures increase, we see a growing number of melt ponds. As this heavy meltwater forces its way into cracks, ice shelves weaken and can ultimately collapse. After 12,000 years, the Larsen B ice shelf collapsed in just 5 weeks. Offshore, sea ice forms when the surface of the ocean freezes, pushing salt out of the ice. The cold, salty surface water starts to sink, pumping deeper water out of the way, powering global ocean circulation. These currents influence climate worldwide. Most ice exists in the cold polar regions, but we see glaciers like these in the Andes all over the world. Most are shrinking. Here in North America, millions of people experience the cryosphere every year. eastward moving storms deposit snow like thick paintbrushes. Mountain snowpacks store water. Snowmelt provides 3/4 of the water resources used in the American West. Substantial winter snows produced a green Colorado in 2003, but drier conditions the previous year limited vegetation growth and increased the risk of fires. In the Rocky Mountains, there are patches of frozen ground called permafrost that never thaw. These regions are unusual in the mid-latitudes, but farther north, permafrost is more widespread and continuous, covering nearly 1/5 of the land surface in the northern hemisphere. Sea ice varies from season to season and from year to year. Data show that Arctic sea ice has shrunk dramatically in the last few decades. The effects could be profound. As polar ice decreases, more open water could promote greater heating. More heating could lead to faster melting, reinforcing the cycle. If this trend continues, the Arctic Ocean could be ice-free in the summer by the end of the century. These changes in ice cover are not limited to oceans. Greenland's ice sheet contains nearly 10% of the Earth's glacial ice. Glaciers in western Greenland produce most of the icebergs in the North Atlantic. After decades of stability, Greenland's Jakobshavn ice stream, one of the fastest flowing glaciers in the world, has changed dramatically. The ice has thinned and the front retreated significantly. Between 1997 and 2003, the glacier's flow rate nearly doubled to 5 feet an hour. These are just some of the cryospheric processes that NASA satellites observe from space. Continued observation provides a critical global perspective as our home planet continues to change day to day, year to year, and further into the future.